Hi all! Let us consider the equation of a line. You are probably familiar with the equation y equals ax plus b. This can describe any line, except for the vertical lines. Those have to be described by x equals c for some constant c. The method described in this video gives a unified way of dealing with both types of lines. But that's not the main point to look at it this way. Indeed, the main purpose is that it generalizes nicely to higher dimensions. For example, to find the equation of a plane in 3 dimensions. Okay, suppose you have a line and you want to find its equation. The main feature is that we need a vector n equals ab perpendicular to the line. We call n the normal vector. Take a point P and then another point x, y is on the line if the vector x, y minus p points in the direction of the line. This means that n is perpendicular to the vector x, y minus p. So their dot product should equal 0. This gives dot product of n with x, y minus p equals 0. So n dot x, y equals n dot p. Writing n is ab and n dot p is c, and expanding this equation gives the standard form for the line ax plus by equals n dot p equals c for some fixed value of c. For example, for the vertical line through the point 3, 2, the normal vector is 1, 0, so a equals 1 and b equals 0. Thus, we find for the equation 1 times x plus 0 times y equals c. To determine c, we take one point on the line, for example 3, 2, and plug it into the left-hand side, which gives 1 times 3 plus 0 times 2 equals 3, which is exactly the dot product of 3, 2 with 1, 0. A more interesting line is a line through 2, 1 and 4, minus 2. To find the equation for this line, we need the normal vector. The direction of the line is from 4 minus 2 to 2, 1, so it's 2 minus 3. You obtain the normal vector by swapping the two components and multiplying 1 by minus 1. Indeed, the vector 3, 2 is perpendicular to 2 minus 3, as their dot product equals 6 minus 6 is 0. Thus, the equation for the line is 3x plus 2y equals c. And we obtain c by plugging in any point on the line, for example 2, 1. So c equals 3 times 2 plus 2 times 1 equals 8. The line is thus determined by 3x plus 2y equals 8. And indeed, plugging in x equals 4 and y equals minus 2 gives 12 minus 4 is 8 as well. To connect this last line to the form you already know, you can rewrite it. First, 2y is 8 minus 3x, and thus y equals 4 minus 3 over 2x. Likewise, you can rewrite any equation in the form y equals ax plus b to minus ax plus y equals b. And from the last formula, you can read off the normal vector minus a, 1 by taking the coefficients in front of x and y in the equation as the components of the normal vector. In a later video, you will learn about another way of describing lines with vectors using a parameterization. But before that, there are some good exercises about this formula. Goodbye.